And so we're going from like 20 years ago, like bedroom hackers, bored PhD students, people like messing around, like kids, basically being kids, yeah. And the kind of security controls you need to deal with those versus the kind of security controls you need to deal with a Cold War era funded like national project is just an astronomical difference, right?
Well, hello, and everyone, and welcome to your bi-weekly doses of salty knowledge, brought to you by Marty, the cool recruiter. Join me as we scour the 7 seas of tech in search of some salty knowledge. And today, with me in the cabin, I have the one and only Phil Wise, who's an experienced technology leader, someone who, I've got a knack for, bringing people that have experience building teams, especially software teams, and that's Phil. Phil has been doing quite a bit of that, but he'll be telling us all about it. He's currently working at Snyk. My understanding is that Snyk provides security tools or code for developers, right? Basically, but he'll tell us more about it. But the drill, he knows the drill. We all know the drill. Now we want to know something about you, Phil, that very few people know outside of close friends, or bring us in on some cabin gossip.
Cool, thank you, Marty. Yeah, so here's a fact that most people don't know about me. Is actually my first job when I was a teenager was ringing church bells for weddings. So I think I've probably attended more weddings than most people have who don't otherwise officiate in them.
For weddings, no less, right?
Yeah.
That is.
It never rains
and you're
on
talking.
Weddings. That's a fact.
It never rained.
Never. I must have shown up to I don't know how many weddings as a child, like basically two every Saturday for the whole of the summer in England for international guests, and I could count on the fingers of one hand the number of times that was actually rain, like on that moment. It never rains. Never rains wedding days.
Well, actually, for Chinese, it's a good sign. If it rains during a wedding, that means that the couple is going to have many children, like a large family. It's a sign of fertility or something. I don't want to be quoted on this or anything, but my first girlfriend was Mandarin. Like she was from the east part of China, Cantonese, and she spoke Mandarin. And that's one of the things that I still remember. That was way back, but the color red, it brings luck, and rain at a wedding brings fertility. So Snyk, man, I gave the listeners a description of it that's very, very high level, but maybe you can fill in the details.
So Snyk as a company makes security software, so helps people who are, for example, CISOs at large organizations manage their security posture. They run an awful lot of software, and we make some tools that help with doing that. And in fact, inside that, my team deals with some code that analyzes people's source code. So you've got lots of developers at a big organization. They write a lot of software, and it's a matter of understanding what does that software actually do, and what does it do. And if we know what it does, then we can start asking questions like, is this software secure? Which is a really interesting problem. Actually, it's at the intersection of some really hard computer science problems. So actually, the problem is fundamentally unsoluble. Even the simplest possible question you can ask about a piece of software you can't answer in the general case. So if I give this piece of software some input, does it exit? Does it finish, or will it run forever? Which is, it seems obvious, right? It seems such a simple question. Like, here's my program. Does it ever finish? And that's no input, fixed input. And the answer is you can't tell. In the general case, but in some specific cases you can, and very often for the kind of software that people write, you can actually write some software that does get to the bottom of this question. But from the point of view of building a piece of software systems, normally you design a piece of software so it works in all cases, right? That's a much easier thing to do. But whereas what we're doing, actually, we know that the works in all cases is impossible, and you can always construct a thing which isn't soluble, and so actually, but you can get sort of arbitrarily close to it. So it's like one of these exponential amounts of work type problems, where you can add tricks and you can understand this and you can understand that, and it builds into a system which can actually, in practice, when you throw
a piece of code at it,
numbers of lines of software that some of our customers have, that thing, it understands it and can give answers. Okay, there's a security issue down here. So it's when we were at previous places, we used to have this thing about looking for interesting computer science problems in the stuff we do. And lots of sort of the software industry, there's not that many kind of exciting, difficult computer science problems, and they're relatively rare. Whereas actually, this particular problem is interesting because it's a really hard computer science problem, and it's quite good fun to be working at a place that has that kind of technical challenge, as well as all of the other stuff related to being a big company.
How big is your team? I wonder. How big is your engineering team?
10 of us on my team. Yeah.
I find it's the perfect size for a manager, for an engineering manager. It's a specialty of mine. I've placed quite a few engineering managers. I've been a software engineer myself, and from what I've seen across various startups is that if you have like around 10, it's manageable. If you get more than that, you kind of need like some level in between, right? Yeah,
it's the limit where you can be an engineering manager. You can obviously have as many direct reports as someone will let you have, but actually doing the work of engineering management, there's a limit, and the 10's about that. Like, any more than that, you have to introduce a bit more structure, and you can't be actually providing that kind of EM value to all those people.
Gotcha.
There's not enough hours in the end to do all that.
To do that, yeah. And you have had experience putting teams together, like building teams, so rounding up those 10 or so engineers. And one question I always like to ask, because many of our listeners are they're founders or they're hiring managers themselves, is do you have any tips that you'd like to share, or lessons learned from the field of building teams, building high performance team? Like
so where to start? So bizarrely, I've been doing this for quite a long time. For whatever reason, straight out of university, I got given the task of hiring some more people, because we were rapidly growing a team. We did memory controllers was my first job. So I wasn't managing at that time. I was an individual contributor, but we were managed to get on the hiring track quite early on in my career, and then have been doing it more or less non-stop ever since. So it's an interesting field. I think I guess the best piece of advice, which is actually something I got right at the start, was from an old boss back at Altera. It was Steve Perry. I remember his name, and he said it's easier to find jobs for people than it is to find people for jobs.
Gotcha.
And so he was always hiring, Like always, he'd have one job open all of the time, and people would turn up. And you know what? If you keep waiting, like real gems just show up out of absolute nowhere.
Absolutely.
And so a couple of companies ago, we were a relatively small startup, successful, bootstrap, making quite a lot of money, but based in London. So we didn't have the deep pocketbook to compete with the big tech folks for the best hires. But you know what? You just keep looking, and all of a sudden, someone who's absolutely excellent just shows up out of nowhere, and you're like, we've said no to so many candidates back to back, and then this is what we're waiting for. Like, got one, right? This person,
right?
Whatever, like, have them. And it's always that thing of like, you be sure in yourself. Like, no, I know we can get someone, and they do just show up.
They do, and the trick is to be able to spot them, right? Spot the diamond, and sometimes spot the diamond in the rough. And so some of the great clients that I've worked with, they would encounter someone like that. There's that. I call them A players, but there's something special about them, and even though they wouldn't have like a specific job description fitting that profile, they would still bring him or her on board, and again, like tailor or create a position on the spot for that person, and they're few and far between. So when you do encounter them, the idea is to be able to bring them in, right?
Yeah, they're great, and they just get so much stuff done.
And at the polar opposite of that, you have that recipe of throwing more developers at a problem. I've seen that happen where a project would get late, and they would just hire more people, like just the sheer volume of developers, and figuring that, well, if you throw 10 times more developers, it'll cut your production time, but it's not entirely true, right?
Yeah, I mean, it's funny to hear things like that still being said, right? Because the Mythical Man Month, which was like the book that started the software engineering business, like they thought that was going to be a solution when there was the IBM System 360 project, wasn't it? They thought that was a solution then, and they did it, and it didn't work, and it cost them like huge amounts of dollars. You can obviously forgive Fred Brooks, right? No one had ever done that before. Like, he was the pioneer who crashed on this thing and wrote a book about it. And I guess I feel less sorry for someone doing it 40, 50 years later. You can't adding people to a. I think that's the title, but adding people to a late project makes it later.
No, what's the I think I think I saw PHP somewhere along the lines. Is Snyk it's not is it the tech stack isn't PHP, right?
No, it's not PHP. It's all the stuff we write is all C++.
Sure.
There's other stuff across the stack, but PHP is not a terrible not a terrible language. I mean, it's interesting. PHP is actually quite an interesting language in my opinion, because if you ask anyone who's got an academic background, like the strongest response will probably be from someone who's just graduated like a fancy university, but it's still pretty responsive. Like, PHP is a terrible language. You'll get that from pretty much anywhere. And I said, okay, list me some languages which are better. Okay, right. You get some answers depending on the flavour of the month. It might be Haskell, it might be Lisp. There's a whole bunch of things like that. And so just going to have a quick check on the top 100 websites and just find out what they're implemented in, just for fun. Right, let's just do that. Let's just do that experiment. And the last time I did this, admittedly a while ago, right, PHP had multiple hits on the top of the top Alexa, like most common websites, and there was a smattering of your other kind of likely languages and all of the fancy languages that these people have told me are much better are not actually on that list at all. And so I'm a bit of an empiricalist in my technological decision making, and I'm like, you have to read something into that, right?
That it's being used. Why do you think? Why do you think it is widely used like that?
I don't really know. I think I think in the world of computer science, or no, computer science, no, in the world of software engineering, we actually have a massive lack of empiricalism, like actual research, which will meet the bounds of like basic sort of science research. Like, we actually know this fact to be true, and we don't really have anything more. Like, my fact there about PHP is, well, was at the time, at least last time I checked, true. Like I mean, I can stand by that. Those websites definitely run those languages, and they're definitely popular, and there's no question. But let's take even like non-controversial questions. For example, Agile is better than Waterfall.
Right.
Like, most 90+% of the people in the industry would agree with that statement. You just find the research that shows that that's true. And as far as I'm aware, there isn't any.
There isn't any, exactly.
No.
Exactly.
I mean, experience says there is some wins, but what's the scale of that? We kind of don't know. And we've seen it again recently with the whole microservices are better than monoliths thing.
Yeah.
And that, so there's a definite fact that large, well-resourced companies are, for necessary reasons, re-implementing their monolith as a set of broken-out services. And they're probably getting some wins from that. Like, on the other hand, you don't see lots of startups succeeding on the basis of things that aren't large monoliths. And so actually the evidence that I would the result I would take from that is perhaps building this thing as a traditional monolith is necessary to get big enough for that thing to be a problem. And so that's effectively the opposite advice to someone stood up at a tech conference pitching you should do microservices, because if you're Spotify, you know about this problem already because you'll die because of it, and if you don't have the problem and you're deciding what to do, then perhaps actually the right decision is not microservices, it's the other thing. And then when you've got like 1 billion customers, you can start worrying about about this other thing.
That's what I see usually with clients is they build that big, like they go for what's the quickest to gain some traction. They're dealing with a limited runway, so they put something together, they put an MVP together, they start building on that, they start acquiring users, and generating revenue. And at some point though it becomes a bit unwieldy, and then they start like breaking it down into like rewriting it with microservices, with sometimes successfully, sometimes not so successfully. And
you're talking about superstars, and like good people exist, and there's this thing about 10x engineers. That was a thing, and that seems to have that's like post-peak hype cycle for 10x engineers. I mean, they definitely exist. Like, there were some really good engineers, but something like I've definitely seen are 10x teams, similar teams of people. In fact, there's similar kind of capabilities, and some of them just outperform the others 10 to 1. Like 2 people over here doing more stuff than 20 people over here, or 10 people here doing more stuff than 100 people over there have done. And
how do you put a team together that's a 10x team? What's the secret recipe? Do you have any?
So here's an interesting one. Like, if you had a list of say 100 100 things that should work in an engineering organization, right? Like we could come up with that, right? We could come up with that list now. Like, you need builds that are reasonably quick. You need some sensible processes. You need to be building the things that your customers actually want. Like, we could list 100 of those without.
Yeah, true.
And then if you took an average organization, okay, right, can we honestly tick every single one of those boxes? Right, I'm not going to tick every single one. So what score do we get? Okay. So let's say we go through this process, and we score, I don't know, a bad team might score, say, 40% of that process, of those ticks, right? And then, okay, each one of those is worth, say, 10%, right? So if we've got 25 more ticks on that list, right, we're now from 40% to, what's that, 65%, right? Like how much better do you think that team is? Yeah?
Yeah.
40%, 60% on that score, yeah? It's like a C- to a B+, depending on where you're grading,
Roughly.
you know. But no, 25, 10% improvements, yeah? It's 10x. They compound 10x more, right?
Gotcha.
So there's a 10x team, yeah? And we're not even scoring very high on this list, yeah? We're just not making as many really bad, not just leaving things on the floor. And I think there's a lot of value in like not doing anything terribly. Just
so those improvements, they sort of multiply one another, is what you're saying, or
exactly.
there's an exponential effect to it, right? Yeah.
Yeah, they compound. So, for example,
Yeah.
You build the right thing. That compounds with, we saved half an hour off our build process. So now, every time the developers make a change, the change is a little bit better. And every time we release something, rather than just being kind of what the customer wants, we're exactly what the customer wants. And they all add up. And it's very easy to get into an environment where kind of nothing works. And people get used to that quite quickly because they move their measures of success not from did we actually make the product better this week, but did I successfully navigate our coding, testing, CI, QA, whatever process to the end, and I moved some tickets and made some Git commits and did lots of other activities. I successfully achieved all of those activities, and it took me the entire week, and therefore I'm happy with what's going on. But that's not actually the same as delivering some value. And I think that's actually one of the key engineering manager things is to look into what's going on and say, are you really? What's going on here? You hear about these things, like people complain and bitch about the stuff that doesn't work. And so it's not that hard to find these things. You just have to listen a bit, and they'll tell you.
You're one of my first guests from across the pond, right? I'm located over here in Canada. But what's the tech scene like over there in the UK? Say, because here it's and it's been a rocky year in 2023. Now we see things are picking up a bit, but man, it's been quite the stormy waters on the ocean. So what was it like in your end of the world?
It's definitely not where things were at the peak a couple of years ago, where things were generally basically nuts. And I think everyone who's seen that world, who's seen things a bit of time, could recognise that wasn't going to last forever. It was good days though, happy days. Now it's back down again. It's not terrible. Places are still hiring. They're being a bit more realistic. There's less VC money sloshing around, funding all sorts of stuff, which I think, was it Warren Buffett said, when the tide goes out, you figure out who's been bathing with no clothes on. And
man, I love that. Oh, I love that. I love that.
Yeah. And so I think there's a bit of a sort of reconciliation, and now it's actually becoming cool to be profitable again, and some of this sort of we're going to do everything in the cloud, we're going to outsource everything regardless of the cost multiplier for doing so. That kind of world is like getting squeezed, and those things are I think they're going to ripple through the industry a bit, because you've got the companies at the top spending less money on some of the services they were using, and so there's sort of less money going down the throes, and so the companies which have built good, efficient, sensible software are in a good place, right? You can I mean there's still value in all this stuff, right? But the old days of we'll create this value and we will also go and waste a whole bunch of money on some other stuff, that's kind of going, and now it's right, where's the value that we're creating, and let's deliver that and
focus on that.
Focus on just that piece. The problems of software security, things don't go away, right? You still want to you still need to solve that stuff. Back in the early days of the internet, there was the Eternal September, which was basically the original internet was a bunch of academics and US government research organizations chit-chattering over a network that was, and it wasn't private, but the only people who had the time and resources to get in all kind of knew each other. And so there wasn't really a need for security to a high level. Right? Whereas, the security, so ARPANET was all about nuclear command and control, right? So the security inside ARPANET was pretty minimal compared to the kind of security on the gates for the building where all this stuff was taking place, right? There was fences and armed guards and watchtowers and cameras and everything else, right? And that makes sense when the only people you're defending against is like bored professors in Oxford. What we're starting to see now is serious investment on the attacker's side, driven by cryptocurrency, which allows private individuals, effectively organised crime, to run a significant operation with a significant sort of salary, a significant salary bill, and also like serious investment by governments in cyber offensive capabilities, right? And so we're going from like 20 years ago, like bedroom hackers, bored PhD students, people like messing around, like kids, basically being kids, and the kind of security controls you need to deal with those versus the kind of security controls you need to deal with a Cold War era funded like national project is just an astronomical difference, right? The attackers have gone from one person on a Sunday afternoon to maybe you look at the scale of the teams that were working on Cold War era stuff. Hundreds, thousands of people, full-time employed professionals with an organization behind them to get stuff done, right? That's the kind of security threat which we're kind of
facing
into, that you think about the kind of serious defenses that the people who want to defend against this stuff do. That's kind of where we're moving to in the world of software security.
Hey, listen, we're about wrapping up the hour. I'd like to ask you, I like to ask my guests if you have any parting words of wisdom, perhaps, that you'd like to share with our listeners. And now's the time to wax philosophical, if that's your thing, or parting words of wisdom. I'll leave the question
words
open.
Of wisdom. Here's parting words of wisdom. So one thing I think was really interesting learning from He was the CEO back on my Redgate days, Simon Galbraith. And what Simon would always say in meetings was, like, what you're trying to do, okay, right, who's the world expert on this thing? First question. And second question, like, why haven't you made contact with them already? Like, can we get them as a consultant on this project? I think that was a really, really strong thing. And it makes a lot of sense, right? Do you remember the first time you ever tried to boil an egg? It's probably a while ago for both of us now, but like the first time you tried to do that, yeah? Did it come out right?
Yeah. No.
Like,
no, not at all.
Like, boiling an egg is not a hard problem, yeah? And the first time, everyone screws it up, yeah? So
yeah,
the next problem, the problems that we would be talking about in meetings with the CEO of at the time 200-person company, they were a lot harder than boiling an egg. And when we went into those meetings saying, yeah, we're just gonna do it, it'll be fine, we kind of know what to... No, actually, yeah, there's a lot of value in, okay, find somebody who's done it before, get them on boards, use that expert because they're an expert. They've failed a few times already, and don't need to pay my money on figuring that stuff out. Like, let's just learn it from a proper teacher. Yeah,
like in the case of the egg, just ask your mom, right? Hey, mom, how long to boil an egg?
Yeah, show me how to boil an egg. Right. Or
show me how to
boil your own egg, but on your own time. You know.
And make sure you have more than one.
Yes, exactly. When it actually matters, when there's a dinner party on, yeah, there's not the time
to do it
the first time. Yeah.
No, for sure, absolutely. Well, thank you very much, my friend. Thank you very much for taking the time this morning for me, this afternoon, evening almost for you, and appreciate that a lot.
Super. No, thank you very much. It's been an absolute pleasure to speak with you.